You recall that I described our course project as being a menu-driven program, or at least it will be. Now, menu-driven implies that the user will be presented with a series of choices, and depending on which choice they choose, our program will do different things. For example, if they choose to create a record, then we will execute the creating record code. If they choose to delete a record, then we'll execute that code instead. So in order for us to be able to do this, we need to explore the language constructs that the Bourne shell offers to allow us to execute code conditionally. In other words, if a certain condition has been met, then execute the following piece of code, and if some other condition has been met, then execute some other piece of code, and so on. So, the aim of this chapter is to get us to the point where we can modify our course project and add conditional code to it. Specifically, we want to add a menu to it. So let's begin. We'll begin with the most important concept that we have to learn in this chapter, and that is the notion of true and false. Now, we probably already understand what true and false is from a social perspective and probably even from a logical perspective. But we need to understand true and false as it pertains to shell programming. So let's look at what I mean by that. The first thing that you need to know is that when every Unix command completes, it does something that you probably are not aware of. It actually invisibly returns a value to the program that started it. Now, the program that started it is usually going to be the shell, either your login shell or the shell script that you're running. So a value gets passed back from the Unix command after that Unix command has completed, and it tells the program that started it, the status, the completion status of that command. Let's look into that in a little more detail. The value that gets passed back is actually a number, and we call it the exit status of the given command. Now, this has been happening all the time ever since we've started using Unix, and most of us are blissfully unaware of the existence of this exit status, but it's there. We usually ignore it, as does the shell. But we're not going to ignore it anymore. It's actually pivotal to this entire chapter. So let's have a look at it. An exit status of 0 usually means that the program completed with no error conditions arising. Now, what might be an error condition? Well, if you did an ls, for example, of a file that didn't exist, ls might return an exit status to the shell that called it which would be non-zero. A non-zero would mean that some error occurred, and the error that occurred in this particular case is the file is not there. So again, if you ran ls a second time, and this time you asked it to list a file that did exist, then you would probably get an exit status of 0. Now, this is all convention. It doesn't have to be an error condition, of course. For example, the program diff is used to compare two files, will actually return an exit status of 0 if the files are identical, and return an exit status of 1 if they're different. Now, 1 typically means that some error has occurred, but not in the case of diff. It simply means that the files are different. That is not necessarily an error. So, is there any way of actually examining this exit status to find out what it actually is? The answer is yes. The exit status of the last command that ran is always stored in a built-in variable called question mark. It seems like an odd name for a variable, even an illegal name, but nevertheless that's where it's stored. So you can have a look at it at any time using the echo command, just going echo $question mark. You can examine the contents of this variable at any time, and every time you run any command at all, including just examining the status of that variable, then that's the contents of that variable get overwritten once that program completes. So that $question mark is constantly changing. Let's have a look at one. Let's have a look at how that actually works. So the first thing we need to do, of course, is to actually run a command. Let's run the ls command. Okay, so there's an ls running. Now let's find out whether ls returned an exit status to us. Well, it will have. Let's find out what it is. And it is 0. So let's try that a second time. Let's say ls, and this time we'll specify some file that definitely does not exist. And we get an error message on the screen, but we also get, if we know where to look, an exit status of 1. Now, just to prove that last comment that I said, I'll run echo $? A second time, and notice this time it's 0. Why has it changed? Well, it changed because that first occurrence of running echo $? Is actually a command, and that command produced an exit status of 0. So when you run echo $? A second time, you get to see the it's confusing, isn't it? The exit status of the echo that we just ran just a moment before. Now, one thing I want you to keep in mind is that these exit statuses are not absolutely reliable. You'll generally find that virtually every Unix program you ever run adheres to this standard. In other words, if the program completes with no errors, then you'll get an exit status of 0, and if the program produces some sort of error, then it will let you know via the exit status. But you can't rely on this. Some programs have not been designed that way. And some programs, such as diff, actually use the exit status to tell you various pieces of information, like there were differences or there were no differences. Anyway, let's look into exit statuses in a little more detail. Here's the important thing for this particular chapter. It is actually useful for us, the shell programmers, to think of this exit status as a true or false value. And you think of it like this. 0, which really means no error, you can actually think of as meaning true. And any other value, any non-zero value, you can think of that as meaning false. What it really means is there was probably some kind of error, but we'll think of it as meaning false. Now you'll see why in a moment, but before I mention that, I'll just add that in some programming languages it is exactly the opposite. In other words, in C, for example, C treats the 0 value as false and anything else being true. And in C that really is true and false, whereas in the shell it's not really true and false, it's really error and no error, but it's occasionally useful for us to think of those errors and no errors as being true or false. I'll show you examples of that shortly. Interestingly, there are actually Unix programs called true and false that can demonstrate the use of these conventions, and I'll just show them to you briefly. There is a program called true, and I run it, and it does absolutely nothing except it produces an exit status of 0. Similarly, there is a program called false, which also does nothing except to produce an exit status of 1. They're not particularly useful programs, but keep them in mind because occasionally a use for them does come up. It's often useful to have a program that does absolutely nothing for your shell script, and it's also useful if you want to create an infinite loop or a forever loop, and we'll look at loops in a later chapter. But for now, I just want you to cement into your head this notion of an exit status. Go and have a play with some of your favorite programs. See if you can get them to produce an error, and if they do, have a look at their exit status. And if they don't, have a look at their exit status anyway. We'll begin our examination of conditional command execution by looking at a very rudimentary way that you can cause a command to be executed based on a given condition. So let's look at that rudimentary way now. The condition that I'm talking about is always expressed in terms of the exit status of another program. That's what we just looked at, the exit status from the last module. That is always used as our condition upon which we should run another command or not. So that's the way you can think about this whole chapter, if you like. If we are to run a particular piece of code or not, the condition that that is based on is always related to whether one program exited with a 0 or a non-zero exit status. So, as I said, let's have a look at the first rudimentary way of doing that. And this is how you do it. Command 1 ampersand command 2. Now what that does is it means that command 2 will only run if command 1 completes with an exit status of 0. So you can think of that meaning as if command 1 completed with no errors, or if command 1 returned a value of true, if you like, then run command 2. There's another one. it's using the double pipe symbol. A C programmer will be familiar with that double pipe symbol. They'll know that it means OR, and that symbol means essentially run command 4 only if command 3 completed with an exit status that is not 0. In other words, if command 3 produced some kind of error, then run command 4. Or, put another way, if command 3 returned false, then run command 4. Let's have a look at some examples of that. First we have a simple example. Do an ls of a file called file1. Now we use the double ampersand, meaning that the second of those two commands, which is actually to copy that file into the /temp directory, that will only run if the ls returned a no error condition. So if you wanted to read that line in a human readable way, you would say run the ls program, check to see if file1 exists, and if it does, copy it into the /temp directory. Another way you could do it is you could say copy abc to xyz, and if that succeeds, then put out a message saying the file was copied OK. Now another example using the double pipe symbol. You can run the diff program. Now if diff differences between those two files, then it will return a value of 1, which we can think of as false, which will indeed cause the second command to run in this case. The second command, because we're using a double pipe symbol, the second command will only run if the first command produced a non-zero or an error exit status, which it will do if the files are different. Finally, if you needed to check for the existence of a file and you didn't want to proceed in your shell script if that file was not there, then you could write this code. List the file, and if the ls returned some kind of error, then the file was not there, so then you would exit. If you wanted to read that in a human readable way, you'd say check the file is there, if it's not, then exit. You could read that another way. You could say the file must be there, or else we exit. Now the only problem with these constructs is that they are very limited. They have a couple of limitations which I'll just mention to you. If your particular condition is met, then you can actually only perform one command. You may actually want to perform several commands. Now yes, it is actually possible to perform several commands by grouping them all together using the parentheses, but that is a somewhat ugly way of doing it, and I don't really want to demonstrate that to you, but it is possible. I'll leave that as an optional exercise for you. And also you may want to specify another command that you'd want to run if the condition is met. For example, with the very first example on this page, ls file1, now that basically says if the file exists then copy it to /temp. Now if the file doesn't exist, you may actually want to put out an error message. So you may want one thing to happen if the condition is met, and you may want a different thing to happen if the condition is not met. And you can't do that using the double ampersand or the double pipe symbols. So this sort of conditional command execution is actually not done all that often. Some people use it, I use it myself, but only in very simple circumstances. So I suggest that you go and have a little practice with these, just for the moment, just to get yourself familiar with them. I'm not going to demonstrate them any further. You can copy down the examples that I've just shown you on the screen, and then we'll move on to the next module. That last construct that I showed you for conditional command execution, as I mentioned, was rather rudimentary. There is a much more powerful one available in the shell programming language. It's known as the if statement. You'll probably be familiar with this if you've ever programmed in any other language. Just about every programming language in the world supports the notion of an if statement. So as I said, it's much more powerful. It's also more readable. Well, it is for me anyway. This is what it looks like. We start by using the word if, then we put a command there. Now what happens at that point is that the command gets run. Immediately that the command completes, the shell looks at the exit status of that command and determines whether we should proceed into the next block of code or whether we should skip that block of code entirely. And if the exit status is a 0, meaning true if you like, then we proceed into the block of code, otherwise we don't. And if we do proceed into the block of code, then the very next word that the shell expects to see on the next line would be the word then. If you don't put the word then in, your shell will give you an error message. Then next it will execute those series of commands, and there must be at least one command, until finally we reach the phi. Phi, of course, being if spelt backwards. In other programming languages you might see this as endif or something like that. And the phi is put there so that the shell knows what point to jump down to if command 1 turned out to be false, or in other words, command 1 produced some kind of error. We would need, of course, to know where to skip down to. We would skip over commands 2 and 3 and so on down to the phi and then continue execution on from that point. So let's look at an example of that. We'll use diff as our example here. We'll run diff, we'll compare file 1 and file 2. Now the reason I'm redirecting the output there to /dev/null is I actually don't want to see the output of the diff command. I just want to know whether the two files are different or not. There's probably a command line option that I can specify to diff to say don't actually display the differences, just use the exit status to determine whether they're different or not, but I couldn't be bothered looking that up in the diff manual page, so I'll instead just redirect the output to /dev/null. Now if you recall, I mentioned before that if diff discovers that the both files are the same, then it will return an exit status of 0, which we can think of as meaning true, and so we will then of course proceed into the block of code. In other words, if the files are the same, then we go into the block of code. So if the files are the same, then we echo out the words the files are the same, then we remove one of them. I guess we don't need two of them if they're the same, and then we exit out of the program. So that's I guess a neat little example of the way you can use an if statement. Let's see something like that in operation. I'll just compare two files in this directory, names.dat and names.txt, and I will redirect the output to /dev/null because I actually don't want to see the output, and then I press enter and I get that little prompt that means you haven't finished your command yet, which is correct. I have not finished my if statement. Then I need the word then, and then I can say echo the files are the same, and then I can obviously remove names.txt, and that'll be enough. I don't need to exit. And phi. So now after I've typed in the word phi, the statement is indeed complete at that point, so it will run the statement at that point. So let's have a look and see what it actually does. It does nothing. That echo command did not happen, so I guess the rm command didn't happen either, which means of course that the files were not the same. Names.dat and names.txt were different. So I guess that's a fair proof that we now have the ability to control whether certain code gets executed or not. Okay, in the next module we will have a look at some extensions to the if statement that make it more powerful than you can see on the screen at the moment. In this module we examine the else clause, which is actually part of the if statement. We've seen that the if statement is actually a powerful language construct. Now that may be, but we still haven't seen a way to do the following two things. Firstly, we haven't discovered how to execute commands if a given command produces a non-zero exit status. The examples that I've shown you so far only execute the given code if a zero exit status is produced. We also want to find out a way to execute perhaps some other commands if the given condition that's specified is not met. In other words, we might want to do one set of code if the condition is met and another set of code if the condition is not met. Now, to this end, there is an addition to the if statement known as the else clause, and the else clause indeed offers us a solution to both of these problems. This is what the else does to the if statement. It's pretty much as you would expect if you've ever been a programmer. Just before the phi, you actually put the word else, and then you put a separate set of commands. So you'll either get the first set happen or you'll get the second set happen depending on the value in command. So in other words, if command returns an exit status of 0, then you'll get the first set of commands, and if command produces an exit status that is non-zero, in other words false, you'll get what I've called another set of commands. Let's have a look at an example of that. It's pretty much an extension of the example that I showed you just a moment ago. If the files are the same, then echo out the files are the same and remove one of them. Else, in other words, the files are different, then echo out a word to that effect, and then also echo out please review the differences, and then we can obviously do the diff again, which will then this time display the differences. We didn't display the differences the first time, we redirected them to /dev/null. About the only thing you have to remember about all of this is that there has to be at least one command in the first half of the if statement and at least one in the second half, or in the else clause of the if statement. So if you think about it, we actually now have a way to execute a command if a given other command returns a non-zero exit status. Now what does that mean? Well, suppose that all I want to do is one particular block of code. In other words, it won't be like the previous example I showed you where we'll do one set of code if the condition is met and another set of code if the condition is not met. All I want to do is one block of code if the condition is not met, or in other words, if the command produces a non-zero exit status. Now let's have a look at how we might do that. Here we're testing to see whether file 1 exists or not, and in this particular code snippet we've decided that if the file does exist, then we really don't care. There's nothing that we want to do if the file does exist. We only want to do something if the file does not exist, and at that point we want to put out an error message and exit the program. So the way we go about that is we actually have a little do nothing command in the first half of the if statement. The do nothing command in Unix is just colon. Colon by itself is actually a Unix program. It does nothing at all. Pretty similar actually to the true and false programs. They do nothing at all as well. So if you like, we have an empty first half of the if statement, and we actually put what we want to do into the second half of the if statement, into the else clause. Now I'll give you some exercises and practice for all of this at the end of the chapter, but for now we're going to move on to the... There's one final addition to the if statement that we still need to look at, and that is what's known as the elif clause. Elif can be thought of as a bastardization of the words else and if. So what do we need them for? Well, sometimes we need to write a piece of conditional code in which there are more than two mutually exclusive options. So far we've only seen a maximum of 2 blocks of code that we can run depending on the value of a certain command. Well, we may want to write a piece of code in which there are 3 choices or 4 choices or 25 choices. Let's have a look at what that might look like. It looks like this. We say if command 1, then we do a particular set of commands from command 1. Next, instead of the word else or instead of the word phi, we put elif, which means else if. So in other words, it will only run if the first command produced a error or a false condition. And at that point we'll run command 2, which will itself produce a true or false value. And if that's true, then we run command set 2, otherwise we run command set 3. Notice that there is the word then immediately after the elif statement, just like there's the word then under the if statement. So that gives us 3 possible conditional code blocks. Here's an example of that. Now, in this particular block of code, I want to create a file that contains a list of all the users that are currently logged into the system, but I don't want to do that if the file already exists. So the very first thing I do is I check whether the file already exists, and if it does, then I put out an error message saying, sorry, the file exists. Now if that fails, in other words, if the ls produces some kind of error message, then we are okay to create the file. So then I run the who command and I send the output to the file in question. Notice that I'm using a variable name, $file, to represent the name of the file that I'm trying to manipulate. Obviously the variable called file must have been set somewhere before we get to this code. Now if the who command with its output being redirected to the file fails, there's only one possible way that could fail, and that is if we did not have permission to create the file, or perhaps the file was a invalid name. But if it succeeds, if we get back an exit status of 0, then we say okay, file contains the user list. Now if it fails, then we can say that we could not create it. So command 1 in this case is the ls of $file, and the command 2 in this case is the who greater than $file, giving us of course 3 separate code blocks. We're not restricted to just 3, of course. We can have as many elif clauses as we like, on and on down the page, giving us as many code blocks as we want, but of course there can only be one else clause. Now I've just noticed a little error in the code that I'm showing you on the screen at the moment. Can you spot it? If you can't, maybe just pause the video at this point and see if you can find it. Well, yes it is. I need the word then underneath the line that begins with elif. So if we wanted several elif clauses, then we would have an elif then code block, elif then code block, elif then code block, and finally else code block, and then the phi. So it only took us 3 modules, but we finally got all the way through the if statement. You recall from an earlier module in this chapter that the only way that we can conditionally run code is by examining the exit status of a particular program. This is how the if statement decides which block of code should get run. Now if you're a programmer, you might see this as a somewhat limited form of using the if statement. You might be used to seeing constructs like if x is greater than 6, or if a equals b, or something like that. And you might be wondering whether the if statement in shell programming is useful at all, because it doesn't seem to support such notions. Well, there is a way that we can actually do that sort of testing, and we're going to learn about that in this module. Now the first thing that we need to know about all that is, and this is for the non-programmers, that in general in a programming language it's usually possible to compare 2 values together and do something based on the result of the comparison. For example, you might want to test 2 values, and when I say 2 values I mean either perhaps 2 variables, or compare a variable with a value and compare them for equality. In other words, is x equal to 6? And do something if it's 6 and do something if it's not 6. We can also test for inequality to see if one is greater than the other, less than, etc., etc. Now it should be noted that the Bourne shell does not natively support such comparisons. The reason for that is that the Bourne shell really doesn't support the notion of integers at all. You might recall that I mentioned earlier in the module on variables that all variables in the shell are strings. There are no integers, so you can't really say if one is greater than another. However, all is not lost. There is actually another Unix program called test that is perfectly capable of doing such comparisons, and we find that the test program is actually used quite a lot when you're writing shell scripts. Whenever you need this particular sort of comparison, you lean on the test program for that. So let's have a look at how test actually works. Suppose we set a variable called var1 to be 10, then we can run the test program and we can test whether $var1 equals 20. In other words, we're comparing var1 with 20 to see if they are equal or not. Now interestingly, test does not produce any output. You don't get a message on the screen telling you whether they're equal or not. All that test does is it changes its exit status according to the results of the comparison. Now the sharp ones amongst you may be already guessing where this is going. So what we can do is we can think of this exit status as a true or false value. This is where true and false really start to come into play, and this is the first time that they actually do. In the above example we say, well, var1 equals 20, that is a test, that is a comparison test. So the statement var1 equals 20 is either true or it's false. and test will return an exit status appropriate to that particular true-false value. In this example, of course, we get a value back of 1, which we've already decided we're going to treat as false. So let's just do a little visual check on that. Is that statement false? Well, it is, because we've already set var1 to be equal to 10, and 10 does not equal 20. So the statement 10 equals 20 is, of course, false. If var1 was originally set to 20, then the exit status of the test in that example would be 0, which of course would mean true. Now, as many of you will have already guessed, test was actually designed for specific use with the if statement, and here's an example of how you might use that. You might have a variable called var1, and you might have another variable called, let's say, max, and we can test them using the -gt option. -gt means greater than, gt for greater than. So we read this, we say if var1 is greater than max, then we can say, well, that value is too large because it's greater than the maximum. So as you can see, this is actually a very handy way. It is slightly long-winded, but it is a handy way of comparing two values. Sadly, we can't use the greater than symbol. The greater than symbol is already used by the shell program to redirect output to a file, as you probably already know. Now, a couple of notes when using test. These are quite important. I really think that you should keep these in mind, or you'll get all sorts of errors in your scripts. The first is, it's the spaces around the equal sign. You absolutely must have spaces around both sides of the equal sign. If you don't have them, it certainly will not work as expected. Now, this is somewhat confusing because when you assign one variable to another, or when you assign a value to a variable, you absolutely must have no spaces around either side of the equal sign. So it might seem to be inconsistent. It's not really, because when you're assigning variables, that's done using the shell, and when you're comparing variables, that's done using the test program. So they're actually different programs. And the second note is that if the variable has actually not been set at all, or has been set to nothing, in other words, you might just type in x equals and then just press enter on the command line, which will set the value of x to nothing at all, then if you actually use that variable with test in some sort of comparison, you'll get a syntax error. Let me show you a demonstration of that before I show you how you can actually fix it. So suppose I have a variable called x and I just set it to nothing like that. That actually works. There's no error involved in that. It's just x is now equal to nothing. So now I can say test x equals 20 and I get an error message. Now, it's a very subtle thing, but I'd like to actually explain why we're getting an error message here. You have to understand that before test even gets to have a look at this command line, the shell gets in and processes the values involved. In other words, the shell will look to see if there are any special characters on that line, and it finds one with the $sign, and it says, aha, there's a $sign. So that means instead of actually having the $x there, I'm going to replace that with the value of the variable called x. And what is in x? Yes, well, you guessed it, nothing at all. So it actually, if you like, you can think about it as the shell comes along and actually just removes the $x from that line in this particular example. Or to put it another way, it replaces it with nothing at all. And so all test sees is the following line, test equals 20, and that's all. It doesn't see the $x, it doesn't see anything. So that's obviously some kind of syntax error for test. It's expecting something to be made equal to 20. So let's now have a look at how we can fix that. We enclose the variable inside double quotes, like so. We say test and then var1. Instead of var1 by itself, we put var1 surrounded by double quotes. Now, it's actually a really good idea to make this a good practice. Do this, well, all the time, unless you can absolutely guarantee that var1, or whatever variable you're using, has actually been set to something. If there is even the remotest 1 in a million possibility that the variable you're testing might not have been set yet, then you must put double quotes around the variable, otherwise you'll get a syntax error with test. So let's have a look at our example again. So now we say test $x equals 20, and we did not get any syntax error. Let's find out whether it is 20 or not. Well, it's not 20. 1 means false, remember? Now, the reason that this actually works when it didn't work before is, well, let's have a look at it. The shell comes along as before and looks for special characters on the line. It finds the $X and removes them completely, so we essentially end up with just two double quotes next to each other, enclosing nothing, if you like. Now, we call this the empty string. Now, technically, the actual double quotes are removed as well. So you might think, well, we're left with completely nothing, like we were left with before. But, interestingly enough, the shell actually treats the empty string as something. It treats it as a parameter. So when the test program runs, it'll find that it actually has 3 parameters after the word test. It'll have an empty string followed by an equal sign followed by a 20. And that's what test needs. It needs 3 parameters in this particular case. Whereas before, when we didn't have the double quotes around it, it would only get 2 parameters, the equal sign and the 20. It's a very subtle thing, I know, but if you don't really understand it, that's okay. Just keep in mind that you should always enclose your variables inside double quotes if there's any chance that the variable might not be set, or might be set to nothing. Anyway, let's move on and have a look at some more options that test offers us, some ways that we can use this very useful program called test. So some of the useful options for test are as follows. We've already seen test whether one value equals another. The test will return a 0, which we can interpret as true if the values are in fact equal. And then we've got the not equal or different, which is an exclamation mark before the equal sign. That's the symbol for not equals in the shell programming language, or rather in the test programming language. We've also got greater than, GT, minus GT, which will actually only work if both value 1 and value 2 are integer values or numeric values. If one of them is non-numeric, you'll get an error message from test. And we've also got minus LT for less than, minus GE for greater than or equal to, and minus LE for less than or equal to. What else have we got? Well, we can just say test value by itself, not really comparing it to anything. And what we will actually get back is a true-false value, and it will be true if the value is actually non-empty. In other words, that variable, if there is a variable, has been set to something. Now, obviously, if you're testing that, then there's obviously a chance that it might not be set to something, and if that's true, if that is the case, that it might not have been set to something, then you really need to enclose value in double quotes. Now, there is an opposite test for that as well, test minus Z, or Z. Z stands for 0, and this will actually return true if the value is empty. It is of 0 length. So those are a bunch of options for testing the values of variables and comparing one variable to another. We also have some other options that can be used with test, and they actually really have nothing to do with variables per se. They have to do with files and directories. So let's have a look at those. We've got test minus F. Notice that the minus F is actually the first parameter to test. Now this returns true if the file that you specified exists and is a regular file. In other words, it's not a directory or a device or something like that. And we've also got test minus D, which is exactly the same, but it will actually return true if the file exists and is a directory. If it's just a regular file, then it will return false. We've got a couple of other options. We've got test minus S, which will return true if the file exists and has a file size greater than 0. Now, it doesn't actually test to see whether it's a regular file or a directory or anything like that. It just tests its size. Directories too can have a size, so bear that in mind. And then we've got test minus R, or test minus W, or test minus X, which will return true if the file exists and is readable or writable or executable, depending on whether you specified minus R or minus W or minus X. And it will only test to see whether it's read, write or executable by the current process, meaning that the file may indeed be writable, but if it's not writable by this shell script, then you'll get a false value. Let's have a look at some examples of those. We'll do a test minus F of / etc/ / password, like that, and we'll echo the result out like that, and that is a regular file. We'll do a test -f of /123/456, and that turns out to be not a regular file. We can test for a directory. We can just test the current directory like that and echo $, or we can set a value, a variable called dir to be /etc/ I don't know, garbage, and then we can test whether that directory exists, like so. And of course it doesn't. Now we'll see if the /etc/ password file is writable by us. Let's check that out. That's test -w /etc/ password, and it is not writable by us. So that's a collection of handy options for test. Now there's a few more that aren't really related to files and directories, and they aren't really related to comparison either. They're kind of special ones. Let's have a look at those. These are used in combination with the options that I've just shown you. Test ! expression. Now you read the exclamation mark as the word not, so you can think of this as returning not the expression. So if the expression is false, then test will give you a value of true, and vice versa. And the expression is one of the things that we saw earlier, like, is the file writable? Then you could say, well, I'll show you an example. Now we've just tested to see whether etc. password is writable, and we found that it's not. So now let's test to see whether it is not writable. And we find that that is true. It is true, so etc. password is not writable. We can also test to see whether two expressions are both true using the -a option. -a is short for and. You can read this as saying test to see if expression 1 is true and expression 2 is true. Now I'll give you a little demonstration of that as well. Here's a little script that ties everything together. We're using test in conjunction with an if statement, and we're actually using an elif clause as well, and an else clause. So the first thing we do is we ask the user to enter a file name, read it in, and the very first thing we do is we test whether they actually did type it in. And if they didn't, then we give them an error message. Now if they did, then the next thing we test is whether the file that they specified exists, using test -f to see if it is a regular file and not a directory. And then we also test using the -a option for and to see if it is writable by us. And if so, we specify the appropriate message. So let's see this in action. The first thing we'll do is we'll run the program, and it says please enter a file name, and we won't. And it says you did not enter a file name. That is correct, I just pressed enter. Okay, we'll do it again, and this time please enter a file name, and I'll just enter some garbage. The file is not a writable file. That sounds pretty reasonable. And how about if I run it again, and this time I say a file name of dot. Now dot is a directory. It's writable, but it's not an actual regular file. So we'll say it's not a writable file. It's actually a writable directory. Let's now try a file that is not a directory. It's a regular file, but it's read-only, and that is not a writable file. That's correct. And finally, we will try a real writable file, which, well, we'll use this one. Test file is the name of this actual program, and everything is fine because that is an actual writable file. Excellent. So that's the -a option in action. Similarly, there is a -o option. The -o is short for or, and you can read that as saying test will return true if expression 1 is true or expression 2 is true. In other words, if either one is true. Finally, we come to a very interesting fact about the test program. Test has an alias, and the alias is the open square bracket. Now that's a very odd name for a program, but that is an actual valid program name. So what I'm saying is, anytime you could have typed in the word test, you can now actually type in the open square bracket symbol instead. Now, why would they do such a thing? Well, let's have a look. It means that our earlier example could have been written like this. Our just test to see whether one variable is greater than the maximum. So we use the open square bracket instead of the word test. Now notice that there is a closed square bracket there on the end of the line. And that's one of the curious features of the test program. If you use the alias of the open square bracket, then test will actually give you a syntax error if you forget to put in the closed square bracket. But if you just use the regular word test, then you don't need the closed square bracket. Let's just check that that actually works. I'm going to rewrite that little script that I just showed you. Let's have a look at that. Here's that script, and now I'll just go to this word test and put a bracket in like that, and I'll do the same thing here. Now, because I'm using the square bracket, I actually have to use the closed square bracket, and I'll do the same here as well. Okay, well actually, no. What I'll do is I'll omit the closing square bracket there, and I'll run this program and see if it works. So it says, please enter a file name, and so I will enter one. Now, notice there, missing close square bracket. So I'll run it again, and this time I'll put the square bracket in like that and execute that. Test 1, 2, 3. The file is not a writable file, that's fine, but notice that I did not get an error message, which means of course that the closing square bracket fixed the problem. Now, why do you suppose that they've invented this particular curious alias for the test program? Well, if you've ever been a programmer before, then you might actually feel more comfortable with surrounding your test conditions with brackets. To your eyes, that might actually look like a more valid use of the if statement, which is, of course, exactly why it was done. So it would look more like an if statement from, say, the programming language C. Now, C uses round brackets instead of square brackets. But the round brackets were already used for something in the shell, so they invented the use of the square bracket. So it's still the test program there, it's still running as the program called test, but it's pretending to be integrated into the shell and just a valid part of an if statement. So that's a little bit of cleverness there on behalf of the people that designed the test program. Now, because using the square brackets is actually much more intuitive when you get used to it than using the word test, or at least I find it to be, and most programmers that I know find it to be, this is actually the preferred use of the word test. Very few people actually write out the word test, T-E-S-T. Most people just use the square brackets notation because it looks better. It looks aesthetically more pleasing to the programmer's eye. So that's it. That's test. A very, very useful program. Probably 90% of the time that we use the if statement, we're also using the test program as well. Okay, let's move on. We now move on to an interesting language construct called the case statement. Cast your mind back to the if, elif, elif, elif statement, and I'll mention, and I'm sure you believe this is true, that when you use the if statement, quite often what you're actually doing is something similar to the following. You've got one variable and you're testing it against a series of values. Perhaps value 1, value 2, value 3, value 4, and you're doing a different piece of code for each one. In this example here, we're testing var1 equal to value 1, and if that happens to be true, then we run the code for case 1, and then the code for case 2, and so on. Now, there's a lot of coding going on here. We're writing out the if statement a lot of times. We're using test quite a lot. We're using the word then and elif quite a lot. And the equal sign, of course, in test is all being quite repeated quite often. Well, there is actually a nicer way of doing it. Nicer in the sense that it looks more aesthetically pleasing and more easy to understand on the screen. It still does essentially the same thing, but there's less work involved for the shell. And this is, of course, called the case statement, and it looks like this. We take our variable that we wish to compare to a bunch of values, and we put it in between the words case and in. And then for each of the different values that we want to compare it to, we put them on a line by themselves, and we put a round bracket after each option that we're comparing to. Then we put the code for that particular option. That might be several lines of code, that might be 100 lines of code, or it might be 0 lines of code. It doesn't really matter. But we put the code, whatever code that we want to run, if the variable happened to match that value. And then we put 2 semicolons next to each other. That is the case statement's way of saying this particular case or this particular option is now over and we're ready to look at the next option. You can actually put those 2 semicolons on the end of the previous line if you want to, which is actually nice to do if there is only one line for each case. One line of code, one option for each case. But if there are several lines, you tend to put the 2 semicolons on a line by themselves. Finally, when you've exhausted all the options, you put ESAC, which is case spelled backwards, just like phi if spelled backwards. So let's see an example of the case statement in action. Here's a little script called case test, and as you can see, we ask for a rock group name to be entered. We read in the name and then we compare that name with 3 different values. Those 3 values can have spaces in them, as you can see with the second example, Dire Straits. And for each case we determine another variable called no albums, or number of albums, and another variable called last album. And finally, after we've determined the number of albums and the name of the last album, we echo out that information to the screen. So it's a pretty simple script, but hopefully it demonstrates how to use the case statement. Let's test to see if it runs. We'll run that now, and please enter a rock group name. How about the Beatles, like that. The Beatles made 12 albums. The last one was called Let It Be. Okay, fair enough. And I'm sure you understand that it would work exactly the same for the other 2 choices. Now, what if we ran that again and we entered something that wasn't there, like Fatboy Slim, for example? Fatboy Slim just made albums. Didn't say how many albums. The last one was called, and it doesn't say that either. Okay, so clearly our script doesn't work very well if the user decides to enter a value that we didn't allow for. So with that in mind, let's move on and have a look at a little extension to the case statement that you can use to cater for such things. So this is somewhat similar to the else clause of the if statement. When you want to have a piece of code that is run if the value of the variable that you're matching doesn't match any of the above cases. In that circumstance, you simply create a case called asterisk or star. It looks like this. You can see we've got a little case called star there. It's exactly as we had before, except that will get run, the code in that case will get run if the value of var1 did not match any of the above cases. Let's go and have a look at that example working in our little sample script. Now in this case I've created a little case called star, and I simply, in that case, echo out the words unknown rock group and exit the program at that point, because really I don't want the echo on the last line of the screen to be done if there was an unknown rock group. So let's test that in action now. And so we'll enter the old Fatboy Slim again, and it's an unknown rock group. Okay, and that is exactly what we wanted to have happen. So I'll now just quickly show you a couple of other simple options that can be used with the case statement that just make it that little bit more user-friendly and useful. And the first one is that it's actually possible to specify that the same code be executed in several different cases, and you might do that like that. You use the vertical bar symbol or the pipe symbol. So here, where I've got code for cases 1 to 3, that actual code there will get executed if var1 happens to be equal to val1, val2 or val3. So I could adjust my little rock group sample script as follows. Instead of just allowing for Beatles, I could allow for the Beatles as well, in case someone decided to type it in like that. And let's test that. And we'll type in the Beatles and the Beatles made 12 albums, blah blah blah. Excellent. Also, it's possible to use wildcard characters to match values to variables. As follows, we can say here D star, which means, of course, anything that starts with a D, just as it does with file names. So we can use the asterisk character, we can use the question mark character, we can even use the square brackets characters, just as we use with file name wildcards. So I'll just give you a little simple example. Suppose that I wanted to make sure that they could enter uppercase or lowercase b for the Beatles. Then what I could do is I could simply change that to a B or a capital B, like that, just as we do with file names. And then I save that and run it, and if I enter Beatles like that, then that actually matches as well. So it will match uppercase or lowercase b in this case. So it's in fact, I really could just do it like that. If it just happens to begin with the word beat, then I'm going to assume that it's the Beatles. Now that might be actually incorrect, but it's certainly a valid thing to do in a shell script. So I'll just test that. Beat, I could even put the beatniks, I suppose, and that probably is incorrect. I very much doubt there was a rock group called the Beatniks that made 12 albums, but at least it proves the feasibility of that particular option in the shell script. So that's pretty much it for the case statement. Here's just a few notes just to keep in mind while you're using it. It's actually a rather complicated piece of code, the case statement, because there's a bunch of new language elements that we haven't seen before that we have to remember and get right, including the word case, the word in, the word ESAC, the round bracket, the double semicolons, the vertical bar symbol, and all the wildcard stuff. I mean, that's all quite complex, and it's all new with the case statement. It's actually a lot less complicated to use an if statement, but it's considerably more code. If you can get the actual typing right, if you can get the syntax right, the case is a lot prettier to use. But like I said, there's a lot of memory work involved. You've got to remember all these different elements of it. So keep that in mind, and it's actually what most programmers use instead of a series of if, elif, else clauses. Second note, you might have noticed during the entire module that I've just shown you that the case statement really doesn't have anything to do with the true or false notion that we created earlier in the chapter, or the notion of exit statuses. It really just compares one variable to a series of values. Okay, keep that in mind, and you're probably going to be fine with the case statement, which brings us actually to the end of this chapter on conditional code. You now know quite a variety of ways that you can cause code to be executed conditionally. Let's move on, and I'll set you some exercises to do for those constructs. Here are the exercises for chapter 5. Firstly, we'll write a simple script that asks the user for their age, and then we'll compare that age to a variable called retirement age, which should already be set somewhere in the shell script. Now, if the age that they entered is greater, then print out a message simply telling them that they should be retired or something. Otherwise, tell them that they are still quite young. Of course, we have to correctly handle the case where the user simply presses enter and doesn't type in any age at all. Secondly, write another script that reads the name of a directory from the keyboard and then checks to see if the name that they entered is indeed a directory. Also, apart from just being a directory, it has to be writable. See if you can do this test on just one line. And if it is writable and it is a directory, then the script should actually create a file in that directory called hello. It doesn't really matter what you put in the file, just so long as there is a file there called hello. And of course, again, we should make sure that we handle the case where the user simply presses enter without entering a directory name. And of course, we're going to modify the course project. I bet you can guess what we're going to put in here. Yep, we're going to present the user with a menu of choices. That was the actual original goal of doing this chapter. And we want the choices to be as follows. 4 choices: create a record, view records, search for records, and delete records that match a given pattern. Currently, of course, you'll only be able to implement the first 2 choices. That's okay, we'll just leave the other 2 blank for the moment. We'll fill them in later on in the course. Now we're going to use a case statement to do this. to determine actually what choice they made. And I'd like that to be numeric. So if they enter the number 1 on the keyboard, then you will go and do the create record code. If they enter a number 2, then you'll do view records and so on. And of course you have to make sure that you handle the case where they don't enter anything at all or some other value that's not a number. You have to handle that correctly. As I said, with choices 3 and 4 you don't have to implement those at the moment. It might be nice if you simply output a message saying that those options are not yet implemented or something like that. And also, of course, remember now that it is actually possible to view the file before anything has been written to it. In other words, what might happen might be the user might start the program, and before they bother to create a record, the very first time they run the program they might decide to view the records, and there obviously wouldn't be any records at that point, so you have to be able to handle that without displaying any error messages on the screen. I'll leave you to decide how you might do that. Anyway, good luck, and of course, as usual, I will be providing written solutions to all of those exercises and to... Okay, here are my sample solutions to the exercises from Chapter 5. Here's the solution to the age question. I've called mine age test, and it is of course available in the Chapter 5 folder of the CD. The very first thing we do is we create a variable called retirement age and we set it to some number. I'm going to set it to 65. Then of course we ask the user for their age, read it in. The very first thing we do is we test to see if they entered anything. Now I've done that test in a slightly different way here, just to show you that there is another way that you can do it. I've put quotes around the age and compared it to quotes around nothing at all. And of course if age was not entered, then age would be nothing at all, so both sides of the equal sign would be the same. I assure you that works, but of course we're going to prove it in just a moment. Then if they made it past that, okay, then we say if $age, and we don't have to put quotes around it now because we know that it's not going to be empty, and we can say if that is greater than retirement age, then echo you should be retired, otherwise you are still quite young. Okay, so let's run that, and please enter your age. Now I'll skip it and press enter, and I get the message, of course, you did not enter an age, which is good. So now I will enter an age, which is say 23, and you are still quite young. Fabulous. And try again. This time I'll enter the age of 100, and I guess I should be retired at age 100, but you never know these days. Okay, so that script seems to be working. We'll now look at the directory script, and this is actually quite similar. We enter a directory name, we test to see in the same way whether it was entered, and specify that they did not enter a directory, and then, and I ask for it to happen on the one line. Here we are doing two tests on the one line. We're saying that the directory name dname entered is a directory and it is writable, and if it is that case, then I'll just put the words well done into a file called hello in that directory name. Otherwise, of course, I'll put out a message saying dname is not a writable directory, so nothing written. Now I didn't ask you to do that, but of course it's not a bad thing to do just in case. And let's test if that is working. And nope, that's the wrong one. Okay, try again. Please enter a directory name. Now I'll skip that. You did not enter a directory. Good. Try again. Please enter a directory name. How about / etc.? And it's not a writable directory, nothing written. Okay. Try again. This time maybe a file. How about the file ~/.profile? And that's not a writable directory, I guess. That is correct. And I'll just try it again with how about the directory name .. which is the parent directory of this, and it must have worked because I didn't get anything echoed out to the screen. So theoretically there should be now a file in the .. directory called hello. Let's go and see if there is. cd .. and vi hello, and there it is. Well done. Okay, good. Let's now examine the working course project. Okay, now I've made a few changes to this. The guts of the program are essentially the same, but I've made a few architectural changes. A simple change at the beginning here. I've said that I'm going to test to see if the file, the names.dat file, actually exists already, and if it doesn't, then I create it. So if I say if the file does not exist, then, well, you can think of that as being a then, but it's really if that succeeds, then proceed to this bit. And a greater than sign at the beginning of a command simply creates a file with nothing in it. I'm not sure if you were aware of that, but it does. You can test that by yourself if you like. Greater than as the beginning of a command line is a valid command. And then we simply display the menu. And I'm using some \n's and \t's to make the output look a little neater, which you can choose to do if you want to, but it doesn't really matter. And then prompt the user for an answer. And read the answer into a variable called ans, and if they typed a space after their first answer, then anything else they typed will get read into junk, another variable called junk, which I'll never look at again. And then I do my case statement. Notice that I've put double quotes around ans, which obviously will test for the case where they didn't enter anything at all. Now if they entered a number 1, then we read in all the contact details, and this is exactly as before. I didn't change a single line of that code, but I did put the 2 double semicolons at the end there. Now if it's case number 2, then show what's currently in the file. Now the file will be there, because if it wasn't there when the program started it, then I will have created it, courtesy of that little test at the beginning of the file. And then this is all the same code as well, and this is all the same code with the little double semicolon at the end. And cases 3 and 4, I simply say that that's not implemented yet, and if they entered anything else but 1, 2, 3 and 4, and I say that was an invalid choice. Notice that I put a little that's a single character there. It's not a caret, an up hat symbol followed by a capital G. It's actually a control G, and control G, as you may or may not be aware, is the bell character, so that will actually put out a little bing to alert them to the fact that they've made an invalid choice. And that's it. That's the end of the case statement, and it's also the end of the program. So let's see what that looks like when that runs. Okay, so we'll run this, and so there's my main menu now. Notice that I had done a clear at the beginning of the displaying of the menu, which causes the screen to be cleared before the menu is displayed, which kind of, I guess, just makes it look a little neater. And then the first thing I can do, I guess, is view the records. Now this should not produce any error messages because I will have created the file. So answer number 2 is there are 0 contacts in the database, which is correct, but there was no error message, which is also correct. And I'll answer now. Well, I won't type anything at all. I'll just press enter, and that was an invalid choice. Now you probably didn't hear the little ding, but I did. And again, how about an answer of 6, which again is an invalid choice with a little ding. And now we'll try to create a record, and it really doesn't matter what I type in here. Okay, so now the program exits, but when I run the program again, I can view the records, and there is 1 contact in the database, and there it is, that rubbish that I just typed. So it seems to be working. Well, I guess I should check whether 3 and or 4 are working as well. So let's just check 3, and the search case is not implemented yet. Okay, good. As I said, this code will be available on the CD for you to check against yours, and if you've done it very differently to that, that's okay, just so long as it matched